Okay, we're going to look at proving identities using compound and double angled identities and some grade 11 identities we learned as well. Um, there is a page in the book where they go over important steps, things that you should know how to do, or kind of hints for how you should approach these problems. I think it might be better for me to go right into the examples and show you how this stuff works. Double angle identities, or this one, the sine of 2 alpha is equal to 2 sine alpha cos alpha. These identities are on your formula sheet. You're also given 3 ways to write cos 2 alpha. 3 different ways you can write it. For the sum of 2 angles and for the difference of 2 angles, there's 4 different formulas. And 2 from grade 11, tangent is equal to sine over cosine, and sine squared plus cos squared equals 1, what they call a square identity. Okay, I think it might be useful just to get into the first example here. So the question is, you're supposed to prove that 1 minus cos 2x is equal to tan x times the sine of 2x. You're supposed to prove that the left-hand side equals the right-hand side. So what you do is you start with one of the sides, and it kind of depends on the question. But this one here, 1 minus cos 2x. So you look at that cos 2x, and the way this game is played, on your formula sheet, you have 3 different formulas that you could choose from. But there's one that's going to simplify this whole question. In fact, if I use 1 minus 2 sine squared, I'm going to go 1 minus 1, and those ones will cancel. I'm going to go minus minus 2 sine squared, and it'll simplify to 2 sine squared. If you choose the other ones, things get more complicated. It's still true, but things get complex. So there's the left-hand side. Well, I look at it, 2 sine squared. Well, it still doesn't look like the right-hand side. So in this question, maybe it's a good idea to just write down the right-hand side equals tan x times sine of 2x. Well, tan x is sine x over cos x. So you try and put everything in terms of sine x and cos x. And sine 2x, well, that's an easy one. The sine of twice an angle is 2 times the sine of the angle and times the cosine of the angle. So I can actually rub out the sine 2x and put 2 sine x cos x. I could write up, and the tan x is sine over cos x. And now it's a matter of understanding fractions. If I'm multiplying by cos x, and this means I'm dividing by cos x, you have to see that that cos x is going to cancel. And sine x times sine x is going to be sine squared x. Well, we've just made the left-hand side and the right-hand side equal to each other. So we can say, therefore, the left-hand side equals the right-hand side. That's what we're trying to prove. Now, you notice we didn't just do things to both sides of the equation. We try and work the left-hand side or the right-hand side to look like the other side by doing algebraic manipulations. And let's take a look at this question. Well, this example here, cos 2x over 1 plus sine 2x. Well, you look at this question and you say to yourself, the right-hand side kind of gives you a hint for what is going to be, what should happen. You've got 3 things to choose from, but the right-hand side says the top should look like cos x minus sine x. Well, that's a good idea then, maybe to replace cos 2x with cos squared minus sine squared. Now, the right-hand side tells you, too, that you've got cos x plus sine x. That's what you'd like to end up with in the bottom. Well, you're kind of locked into what you substitute for sine 2x. So instead of sine 2x, we put 2 sine x cos x. But here's a trick. Sine squared plus cos squared really equals 1. And this is a little bit tricky here, but it's sine squared plus 2 sine x cos x plus cos squared. That's actually the sum of the square of a binomial. So if you go cos x plus sine x times cos x plus sine x, you'll get sine squared plus cos squared plus 2 sine x cos x. You kind of have to do FOIL on that, and really work it out. This cos squared minus sine squared is the same as kind of a squared minus b squared. It's a minus b, a plus b. And this one is really like a squared plus 2ab plus b squared. And that just simplifies into a plus b, a plus b. And now the cos x plus sine x canceled, and it looks exactly like the right-hand side. And we're using two ideas, the difference of two squares and the perfect square of a trinomial. You might have to go through that kind of carefully on your own. The next question is actually a little bit easier in a way. We have 1 minus cos 2x, and look, we go for this 1 minus 2 sine squared, so we go 1 minus 1, it'll cancel. The cos 2x, you've got three things to choose from, but if we choose the 2 cos squared x minus 1, then the 1 minus 1 will cancel. Then you just get sine squared over cos squared. Well, we know what that is. That's tan squared. And hey, that's the the left-hand side. So the right-hand side, we make two clever substitutions, and we simplify it, and then we see sine over cosine is equal to tan. And that's just an example of how these things work. There's lots of questions in the textbook. Those are the two that we started today. And good luck with them. Okay.